they're talking, I got a phone call and it stopped my video. All right, the pressure can be rising or falling, so not necessarily will the pressure stay the same. We can't control what the atmosphere is doing. There's no way we can control that. And so what happens is if, let's say, the pressure is rising. So what happens is that the atmosphere will be put more pressure on the water, which is going to cause the water to go in more, right? But the water going in, we're supposed to be measuring how much oxygen is going in, but sometimes if the pressure is changing, that water moving in might be due to the atmospheric pressure changing. And so therefore, we're going to need a control. What is a control group? A control group is there just for comparison. So we're measuring the rate of cellular respiration. So what we want to do for a control is use something that's similar but not going to do cellular respiration. So what I have for a control group is you're going to make a respirometer that has everything the same, because between a control group and an experimental group, you want everything to be the same besides what you're testing, which is cellular respiration. So you want to use the same amount of cotton, the same number of drops of KOH, same amount of absorbent cotton, and instead of using seeds, what I have are glass beads that are similar in size to seeds, but they're not seeds and they won't do cellular respiration. So what happens is if you put a respirometer also in here, so you can lay respirometers next to each other, there's enough width in the bin. When you do your experiment, you can have several respirometers, and one of those should be glass beads. So when you put, if this is the pipette for the glass beads, the water will go in at first just like it did for the seeds. You're not going to expect the beads to do cellular respiration, right? All right. So the beads we know for sure aren't during cellular respiration. But so what happens is if you see any fluctuation, let's say the beads did move in, then it didn't move in because of cellular respiration, right? So it had to do with something to do with either a change in temperature or a change in the air pressure that's pushing it and making it go in. And so therefore, what the beads is we look at, okay, what's the beads doing? Let's say the beads, I went in there too much. Let's say the beads only went up to here. So let's take this. So here. So let's say it started at 0.9 and went to 0.88. So it looks like the beads took in 0.2 milliliters of oxygen, doesn't it? Did the beads really take in oxygen? No. So this is due not to oxygen, it's due to a change in air pressure. And so what happens is, now if your beads are doing that and you look at your seeds, the seeds then really didn't take in 0.05 milliliters of oxygen. Because the beads, it looks like, took in 0.02 milliliters of oxygen. So what you can do is subtract and take away anything that the beads are doing. So if the beads looks like they took in 0.02, then really, 0.02 of this 0.05 is due to atmospheric pressure. So therefore, the seeds would have only taken in 0.03. Does that make sense? All right? Yes?
Doesn't the KOH create a gas? Or like, does it release fumes like the...
No. That doesn't affect. Is that what?
Yeah. Like, wouldn't that? I was just asking if that would have more pressure.
No, but even if it did, the whole point of this would be, no, it doesn't add more pressure to this, so it's not adding. It's not increasing N in this. Is that what you're asking? Okay, no, it does not. All right, and so that's the purpose of a control group. And so I've had years of doing this experiment where a storm was coming in. What happens with a storm coming in is the pressure falls, and so it releases here. So actually, the storm was coming in, the pressure in the atmosphere was falling, and the beads were actually moving in this direction, the water going back out because it was less pressure here. All right, does that make sense? And so it was real interesting that year. Usually we don't get much movement, but it was really interesting that year. And then if it falls, then that means that you have to add that to this. Does that make sense? Like, I doubt that that's going to happen. It's not supposed to rain on Thursday, and so what I need you guys to do is the second handout that you got, the loose leaf sheet of paper, is an example of a lab that's similar to ours. It's not the same. It's using seeds and respirometers and testing cellular respiration, but it's testing different variables, temperature, and looking at germinating versus non-germinating seeds. What I gave that to you because I'd like you to look it over, and it can give you hints in terms of what you can apply to your lab, all right? So tomorrow you're going to be working with your lab groups in your tables, and Maddie and Matt, I'm going to have you guys work with Joe and Roman, all right? And guys, whoa, we have 2 minutes. What is going on here? You're going to make me keep you to 45. So what I'd like you to do is, so we'll have 6 lab groups. So we'll split half and half. So 3 of you, I'm going to assign the first question, and 3 of you, I'll assign the second question. And so then tomorrow when you come in, I'm going to give you time to actually design and work out a way to test this question, whichever question you have, and to test to see if that's true or not. All right. And before you leave, you have to have me approve your design. So then tomorrow or the next day, which will be Thursday, when you come in, you're going to get started right away and perform your lab. All right, so that's the plan. So the reason why I wanted to point out that I gave you that loose leaf sheet is I would look it over tonight, so because you have to have this designed before you leave tomorrow. All right, so if you have some ideas, you might want to look at it, highlight or parts of that lab that you think might work well for your lab design, and so on. All right, so that's the plan.